Close your Chromebooks.
And that includes you, Rock. And that includes you, Rock.
Hey, close your Chromebook. Rocky, come on. Close your Chromebook. Close your Chromebook. Listen, we're not going to do this every single day, all right? We've already had an issue with this. When I say close your Chromebook, close your Chromebook. All right, so what we have today, we're going to do a lab. We're going to start to try to do quite a few labs next 6 weeks. We'll see how it goes. Not super ready for this, but so remember, if you like to wear flip-flops, I'm going to try to give you ample warning next week. It's obviously not going to be Monday, but we're going to try to do a lab next week. And so if you don't wear the proper clothes, if you don't wear the proper shoes, you're not going to be able to do the lab, and you'll have to take a 0 for it. So I'm going to give you multiple warnings. Please make sure that you heed them. Write a note down, like set an alarm in your phone, whatever you got to do. Make sure you're wearing the right stuff. Yes?
I'll wear socks with my sandals.
No, that's not about socks. I didn't mention socks at all. It's all about the shoes. So you got to either wear the right shoes or you can't do the lab. There's no wiggle room there. Because if you're over there in the lab with anything other than the proper shoe wear, and you break some glass and cut yourself, I'm the one that's responsible. And so literally, you're not going over there unless you have the proper shoes on and safety wear. Yes.
Crocs acceptable.
Huh?
Crocs.
No. Someone asked about that last class. Crocs, unfortunately, are not acceptable. And it's just because the big holes in the open back. So, sorry. So what we have today is a virtual lab. Sapling has a bunch of these. They're all right, but they're not super great, which is the reason that we haven't been doing a bunch of them. But I figured we got a Friday, and just to give y'all something to do so you don't get yourselves in trouble, we'll have a little lab assignment. And so this is going to be pretty simple. There are 5 questions to it, and so I'm going to go ahead and actually assign this right now that everybody's Chromebooks are closed. Save and return course. So, now I was talking about all y'all because I wanted to be able to talk about this before y'all go in and just randomly answer the 5 questions and you're done with it. The whole point of this is for you to actually learn. By the way, if never mind, we'll deal with this later. So what we have right here, you have a hot plate. We actually have these over here in the lab. Let's use this as a learning moment. We have 2 ways to heat up chemicals here in the lab. We have a Bunsen burner and we have hot plates. And so this is our hot plate. It looks a lot like the one they have there. If you're a college student at a non-wealthy college, you will be familiar with the hot plate. Most college dorms don't have kitchens. There's no stove or anything that you can catch the dorm on fire with. And so if you want to cook something, you buy a little hot plate like this. This is obviously a scientific one, not like a kitchen one, but they work the same. Basically, you dial in what temperature you want. This one's set to 385, and it will bring this hot plate up to 385. And if I set a beaker on here with some water, it will start to boil the water. I'm not going to set this on here because I should have done it when it was still cool. But
Could you cook a pizza on a hot plate?
That is the question many college students have asked themselves. The answer is yes, but not very great, more than likely. So that's what your hot plate does. It's literally a plate that gets stuff hot. So what they're going to do here is they're going to heat up your beaker of ice. And we have 3 different things that we can heat up. We can heat up ice, which is frozen water. We can heat up bromine. And we can heat up benzene. So we have 3 different chemicals that we can heat up. We're probably going to see some charting happen here. If you look at this is a thermometer probe. So this is getting my temperature, but unlike the old school thermometers where you have to write down your temperature every minute or every so often, this one's going to record it automatically for you on what looks like an iPad. And so we are bringing technology into the lab. And we're getting more efficient with our use of technology. Just depends on if your lab can afford to buy those kind of things. So here we go. Let's heat up the water. What's going to happen when we heat up ice?
It's gonna turn into water.
It's going to melt. It's gonna do a phase change from solid to liquid, and then it's going to start to heat up. What happens when I heat up my water? It's eventually going to heat up enough where it starts to boil, which is the phase change from liquid to gas, which is evaporation. So notice two things that are happening here. I have two little flat areas. This flat area right now, what's happening to my water? What's it doing? It's boiling. Like you can barely see it because it's not, but it's boiling. So notice that when the water's boiling, my temperature's not rising. I'm still putting heat into the water, but the temperature's not rising. What's happening to the water?
It's lessening.
It's evaporating away, and the level of water is actually getting lower. So there's a couple things to think about here. Water will only get up to a certain temperature before it starts to boil. That's 100 degrees Celsius or 212 degrees Fahrenheit. And basically, anytime I have any water in there, my temperature of my water will not go above 212 degrees Fahrenheit or 100 degrees Celsius because that temperature is being used to convert the liquid into a gas. And so as long as there's some liquid in that water or in that beaker, the temperature cannot rise above the boiling point for water because literally water can't be hotter than that. It would be steam if it was. And so at that temperature, we level out, and all the energy I'm putting in right here is going into that phase change conversion from liquid to gas. Yes?
What temperature does glass melt?
It depends on the glass. So the glass is a generic term. It's pretty hot. It's not as hot as you would think. You can take like a standard flame and melt glass. If we did a lot, I don't know that you do it for a high school class, but for a college chemistry class, you can actually melt glass with a Bunsen burner, which actually doesn't get super duper hot. You melt test tubes and pull them out and twist them off at the end. There's a lot of work you can do, but glass is not that hard to melt. Now, different glasses with different stuff mixed in can have higher melting temperatures. It depends on what chemicals happen to be in it. What?
But bulletproof glass.
That's not really like I don't know. I'm not super clear. There's probably lots of different types of bulletproof glass. And usually what makes glass bulletproof is not the glass, it's layers of plastic in between the glass. So it's less the glass itself and more how it's kind of put together. So we went through water. Notice that water has two flat levels here. And what these are latent heat. This is the heat that goes into that phase change. So anytime I'm not changing from a gas to a solid, from a solid to a liquid or a liquid to a solid, my temperature is rising. So when I'm starting to boil my water after it's melted into water, that temperature is going to rise. But once my water starts to boil, my temperature stops rising until all my water is boiled away. Same thing with melting ice. When I start to put energy in to melt my ice, once it starts to melt, the temperature levels off. And it doesn't start to rise again until all of my ice is melted into water. Then once I'm 100% water, I can start to raise the temperature of my water. Same thing here. It stops rising when I start to boil. It's not until I boil all of my water away at the end that then my temperature can start to rise again. And so that is your latent heat. They might ask you a couple questions about that. So let's switch over to bromine. Bromine's going to do the same thing. Watch how fast it happens, though. It doesn't take very much energy to melt the bromine. And then I have this long area where my bromine is boiling off. And then once it's all boiled off into gas, it can go back up again. So very similar chart pattern from bromine to water. And I imagine when we see benzene, we'll see the same thing. It didn't take the heat. There it goes. So we heat it up. It takes a little while. So notice it's flat. And it's going to stay flat until every bit of ice is melted. And I only have liquid benzene. Now, once the ice is melted, there's still a little bit in the bottom there. Once that ice is melted there, now I can start to heat up my liquid benzene. And then now it's boiling. Once it starts to boil, I can't go up in temperature until all the benzene is boiled away. Once it's gone, now I can go back up in temperature. So note that I'm still putting in heat the whole way, In these areas where my temperature stays the same, that heat's not going to changing my temperature. It's going to changing my phases of my liquid, solid, or gas. And then I think that's it. I think that's all they wanted you to do. So you can reset this and do it again, or you can just go ahead and answer the question. So once you get started, I didn't tell you to open your Chromebook. Close all your Chromebooks. You got 5 questions here. They're all going to ask you about stuff that you found in the lab. If you go to the assignment, this little blue hyperlink will take you to the lab itself. So you don't have to scroll down and find the lab separately. So make sure you click on the link, watch the lab happen. They're going to ask you things like water, bromine, and benzene. What's your melting point? What point did it melt from ice to liquid? What's your boiling point? When did it go from a liquid to a gas? And so they should just ask you questions that deal directly with the lab. Another thing, I have posted on Google Classroom, when I close out the tab, the study sheet for gas stoichiometry, which will have a couple of these word answers in here if you don't know how to answer the wordy questions. And I will post this video to that same post. So if you wait just a minute, I will have that posted. You can now open your Chromebooks and go ahead and start to answer the questions. Now I'm just going to have you all clear your Chromebooks off of your desks.